This demonstration shows Xcelenz GENEXIX-iDT applied to a combined cycle power plant digital twin. The plant is configured as a 2x1 combined cycle system. 2 gas turbines, 2 heat recovery steam generators, 1 steam turbine, balance of plant, and electrical export to the grid. The purpose is not simply to display data. GENEXIX-iDT builds an operational intelligence layer that connects plant topology, live sensor values, FAT and SAT baselines, OEM documentation, and engineering rules into one explainable system view. At the top, the dashboard shows plant status, configuration, sensor coverage, and golden reference confidence. The golden reference is based on acceptance test data where available, and on documented specifications where test data is not available. In the plant overview, each subsystem is shown with its current health status. Gas turbines, HRSGs, steam turbine, balance of plant, and electrical systems are monitored together, not as isolated assets. This is important because in a real power plant, a local deviation can affect the entire process chain. A gas turbine issue can influence exhaust temperature, HRSG steam generation, steam turbine output, emissions, and electrical export. The live single-line diagram shows the same logic visually. Sensors are placed directly on the plant flow path, so the operator can understand where a deviation occurs and how it may propagate through the system. GENEXIX-iDT also compares live data against the golden reference. Vibration, bearing temperature, lube oil pressure, combustion behavior, generator values, and other operating parameters are checked against their expected ranges. Historical CSV data can also be imported. This allows old operating logs to be analyzed against the same reference model, helping identify degradation patterns that may not be visible from one live snapshot. The co-pilot then explains the plant in engineering language. It identifies the configuration, connected systems, critical components, and the operating logic of the combined cycle plant. Now a bearing degradation scenario is selected. The system detects abnormal behavior around gas turbine A. Bearing vibration increases, bearing temperature rises, and related values begin moving away from the accepted baseline. Instead of showing only an alarm, GENEXIX-iDT links the deviation to the affected component, the related sensors, possible failure modes, and the relevant documentation reference. The active deviations panel shows the current value, expected value, deviation percentage, and severity. The system highlights that vibration and temperature are no longer within the preferred operating window. The evidence chain explains why this matters. Elevated vibration may indicate bearing wear, rotor imbalance, lubrication degradation, or thermal stress. Increased bearing temperature can weaken the oil film, increasing friction and accelerating further degradation. The trend view shows how the parameter is moving over time. This helps the operator understand whether the issue is stable, improving, or getting worse. GENEXIX-iDT then moves from diagnosis to action. It recommends reducing load on the affected gas turbine, checking lube oil pressure, taking an oil sample, monitoring wear metals, and preparing maintenance action. It also defines escalation logic, including when controlled shutdown should be considered. Finally, the system generates a grounded analysis report. The report includes plant health, active deviations, golden reference comparison, maintenance priority, emissions and compliance status, documentation trail, FAT/SAT provenance, and recommended next actions. This is the core value of GENEXIX-iDT. It turns complex plant data into traceable operational intelligence. It helps operators understand what is happening, why it matters, what may happen next, and which action should be taken, all grounded in the machine's own documentation and acceptance test baseline.